The world of data science is continuously evolving, and so are evolving the techniques and methods to work with data. In this video, I am going to discuss about one such method or technique known as feature store, which has come recently in the world of data science, and for some reasons it has become very popular. Let's see what are the feature stores. As usual guys, we are going to see what are the topics for this video, and first of all we will learn what is feature store. Then we will learn why feature stores are needed in machine learning. Then we will see different types of feature stores, and we are going to see some key terminologies that can be asked to you in the interview. And I'm going to leave you with some AWS feature store guidance. I'm going to show you how to practice it, where to practice it, and what are the important things you should know in terms of AWS feature store. Okay, so first of all, what is a feature store? A feature store is basically, if you ask in simple terms, right, it is basically repo or repository of your features. Now, all of you know what is feature in machine learning, right? I no need to explain that. All of you know what is feature in machine learning. So feature store is basically repo of features. Suppose if I talk of Boston housing data, then maybe construction year of the house, or maybe area, or maybe longitude, latitude, maybe distance from the sea. All these are different features. So one obvious question comes to our mind that these features are anyway present in the data, right? Then why do we need to worry about creating a separate repository of features? That's a very genuine question. Let's try to understand why feature stores are needed and why a separate repository of features are needed. Suppose let's take a simple analogy from, between, let's say you are two brothers. This is you, okay? This is you, and this is your brother. You are siblings. I'm just giving an hypothetical example. If you don't have a brother, or if you are, single, then that's fine. But just imagine that this is you and this is your brother. Now, both of you claim that you can cook very good noodles. Okay. So one person, you say that I can cook a better noodles, and your brother says that I can cook a better noodles than you. Okay, and there is a judge who can give you the rating on whose noodles is good. So both of you are given the opportunity to go to the kitchen and prepare the noodles. Okay, when you go to the kitchen, then you pick the raw items, such as, for example, cut onions, or let's say, if you need carrots cut, right? And if you need, let's say, I'm just writing ingredient 3, ingredient 4. Okay, all these ingredients you are using in the kitchen. Now the person who is arranging the competition, right, they have created a repository of all these ingredients. Okay, so imagine like this is the repository where you have your ingredient 1, for example, cut onions, your ingredient 2, for example, carrot, your ingredient 3, okay, your ingredient 4, your 5, and so on and so forth. When you go to prepare your noodles, you pick from this repository. Okay, so you go and pick this, and prepare your noodles. When your brother goes, he also picks from this repository, picks, and prepares his own noodles. Now, what my point I'm trying to make here is, both of you are using same source of the raw materials. In the language of machine learning, if you think ingredient 1, ingredient 2, 3, 4, 5 as different features, and this left side Maggie preparation as one machine learning model, and right side noodles preparation as another machine learning model, then both these models, okay, are using the features from the same repository of features. Okay, I'll make it very clear with one more example. So let's see one more example. Suppose you have a housing data in front of you. Okay, housing data. In this housing data, suppose there is a column called date of construction of that house. Okay, date of construction. This is one column in the data. And another column in the data is, for example, let's say this house is vacant. I mean, nobody is living there for some time. Okay, so I'm just telling here vacant since. Vacant since. Okay, so imagine this is a very simple data in front of you. So let me put some numbers here. 2004, let's say 1992, and let's say 2008, year of construction. Okay, and vacant since, I will just put some random dates, for example 0101 2018. Okay, and you can just imagine some dates here. Now let me derive some features from this. So this is basically raw data. Now I will do some feature engineering and I will derive age as one of the feature. So how you will derive age? You will definitely take current year minus that year. For example, first house, what will be the age? 20 years, right? Second house, what will be the age? Some number. Let's not go into odd details. What will be the age? Some number. And here also, I want to derive one more, uh, one more feature. Let's say number of days vacant. Okay, number of days vacant. Okay, and here some numbers will come x, y, z. So again, from the current date, you will subtract this and derive. Imagine you are working on two different problem statements. First problem statement is you want to predict whether this house will go on rent in next 1 year. Just a hypothetical machine learning use case I'm talking here. Predict if this house will go on rent in next 1 year. You will need these two features. Okay. Second use case, if the owner is interested in selling this house, then estimate the price of the house. That use case also, you will be needing these two features. So what are you doing? For different use cases, you are taking the feature from the same feature repository. And this repository is nothing but a collection of age and number of days vacant. Okay. So I hope you got a high level understanding of what is the use of feature repository. Now, this is not all. Let's go to our second point of the discussion where I'm saying why feature stores are needed. So one thing that I explained you till now is feature stores are needed because of reusability of features. Okay, reusability of features. Now 10 different people are working in 10 different projects. All of them may need the same feature. Since the feature is stored in feature store, so they can pick the feature from there. Okay, reusability is one thing. Second thing you need to understand is standard processes. Okay, so for example for example, if the way of calculating age of the house is current year minus year of built, okay, then this process should be followed across the machine learning projects. Somebody should not come and say that I will take this age of the house in months, or just example I'm trying to give. Somebody should not come and say that I will use a different technique to calculate the age. So if you talk about banking and finance domain specifically, right? So there are features, there are things which are very particular in nature. Calculation should be very particular and it should be followed throughout the organization. Okay, so those places, standardization or a standard process to compute some of the features should be followed. That is where your feature store helps. Third example, or why feature store is popular is um, all these things are computing. Okay, so if you see here, I have given example of just two features, but everything is computing. So suppose you are computing like thousands of features on, I don't know, millions of data points, right? So it will eat your resources. Now suppose at one place you have kept all these things computed, so it will help you to save cost. So I'm writing here save cost. Okay, then fourth thing I want to mention here is something known as lineage. Lineage means lineage tracking. I will say lineage tracking means how this particular feature was created. So for example, here I am written 20 and I don't know the formula of, for example, now I'm explaining, I told you I subtracted from 2024 to this, but there are complex feature calculations, right? So how do you track? How did you arrive to that feature, right? So there has to be a lineage tracking facility that most of the feature stores give. Now, another thing that is important in the world of feature store, or why feature store is popular and famous, is um, time travel of features. So time travel of features means, for example, let's say if I talk of this same example, right? So age of the house, as we are in 2024, I will say 20. If I would be creating this video in 2023, I will say, I would be saying it is 19 years old house, right? So you can say that at different points of time, this features value is different. Okay. So feature store normally gives you that facility where you can time travel and see at what point what was the value of your feature. Okay. So these are the reasons for which your feature store is very, very popular. Okay. Now, who are the guys who give you a feature store? So all the big guys, for example, AWS, uh, Sagemaker has a feature store. Then your Vertex AI also has a feature store. Then all the big machine learning players will have, they have their own feature store offering, and also some of the new players have a standalone feature store offering for you to use. So that is about what is feature store and why feature stores are needed. Now, in the types of feature store, I just want to cover this point quickly. So you have to understand the difference between online and offline feature store. Okay. So online versus offline feature store. So basically what is the difference here is the example I was giving you here, uh, uh, age of the house and number of days vacant, right? Suppose somebody is interested in seeing all the historical data for a feature. For example, age of the house today is 20. Last year it was 19. Previous year it was 18. Suppose somebody is interested in looking at all the data points of this feature historically. So what that person will use is something known as offline feature store. Why? Because this is mainly for batch predictions or batch inferences, batch training, you can say, for batch processing. Okay. But in some of the scenarios, for example, credit card fraud detection, or where we need fast responses in the inference, right? Fast responses in model results. So we want to keep the feature store very, very small, and we want to keep it very, very fast, responsive. End of the day, it's a database table. Okay. So we will use an online feature store where only recent values will be stored and it will be fast. So here I will say real time or online prediction inferences. That is where we use online feature store. Okay. Here, as I'm talking of inferences and serving, I also want to add one more thing, one more reason why I use feature storage. There is a concept of training, serving, skewness. Okay. Training, serving, skew. Training, serving, skew meaning is, suppose in the same example, let's say I add another column and I call it old, um, um, old house. Okay, old house. And my definition of old house is any house whose age is more than 20, or let's say greater than equal to 20. So my this house will become an old house. Let's say my below house also will become an old house. My this house will also become an old house. No, this is 2008, it will not become an old house. Okay. Suppose this is how I'm preparing this data in the training. When it comes to inference, right? Let's say, for example, in the inference, when I'm creating my data processing pipeline, by mistake, I say that in place of greater than equals to 20, by mistake, I say greater than 20. So in that case, this data point will become 0. It will not remain 1 in the inference serving I'm saying. Try to understand the difference, guys. I'm talking about this old house column. While training the data, I said that anything greater than equals to 20 is a old house. Hence, this became 1. But while predicting, right, while predicting by mistake in my data transformation pipeline, in place of greater than equals to, I said greater than 20. So what will happen to this data? This will become 0. So this is not correct. So this concept is called training, training serving skewness, or training inference skewness. Means you are treating data in a different way in training and treating data in a different way in serving or inference. So if you use a feature store, right, then these kind of problems will come down or it will not happen only. So this is another reason why you use a feature store. So I've give you a lot of reasons why feature store are useful, why it is used. One more thing before we go to the demo part, I want you to be aware of few important concepts. One is known as feature group. Okay, so feature in the feature store there is a concept of feature group. So what is a feature group basically? So suppose let's take an example of online sales. So here there is customer data. So I will write here customer. Okay, and here there is transaction data. I will write here transaction. So all of you know that from customer also we can create multiple feature, from transaction also we can create multiple features, right? So let's say I will create a feature group 1 where I will put all the customer related features. I will create a feature group 2 where I will put the transaction related features. So nothing fancy here, just similar kind of feature, you group it together and you call it one feature group. Okay. Another concept is known as here record identifier. Okay, so record identifier. Record identifier meaning, suppose from the customer table I have created 5 different features. For example, let's say I will just write here age of the customer, or I will write here last purchase amount, last purchase AMT I will say, and I will say here last logged in time. So many things I can create from the customer, let's say table. Okay, but there has to be a record identifier that can tell me that all these features belong to this customer at this point of time. So one unique identifier which can tell me the customer data for those features. So let's say there is a customer record identifier 11 number customer. Okay, so in one of the machine learning use case, I may need only age column. So what I will say to the feature store is, go to the feature store for this 11 number customer, give me the age. In another machine learning problem, I may need age and last logged in time. So I will say, go to the feature store for this 11 number customer, give me the age and last logged in time. And remember, I can get this data at different time interval also. I mean, different time points also. So what is the use of record identifier? It identifies your one record in the data at maybe different points of time or last updated data. So that is a unique identifier. These are two important concepts in feature store. One is feature group, one is record identifier, and there is one more concept called metadata. So metadata is nothing but you can think it as the way you are storing features and the way you are creating groups, you are creating inside the groups what all features you are creating, all that information need to be stored somewhere, right? So that is nothing but feature metadata. Now let's see some of the practical examples of how you can practice feature stores. So I'm going to take you to two pages here, AWS pages basically. This one is a pretty simple one. If you want to practice, I leave it to you. Go ahead and please practice on this. The concept, whatever I discussed now, will be very, very clear to you. Okay. So if you see here, I'm just scrolling fast, I know, but just the important things I'm taking you to. Okay. So as I was telling you, on one side you have customer data, other side you have order data. Okay. So customer feature group, order feature group are created here, and both are stored in the feature store. If you see how to do this in the code, that also is given here. If you see, so from Sagemaker feature store, I'm not doing it knowingly, because if I do it, I'll be repeating the same information that is here in this. Okay. So I want you to get your hands dirty and learn it. Okay. So from the feature group is imported. Two different feature groups are created, and then there is a event time added. And here, if you see, customer feature group dot create product, other order feature group dot create, feature groups are created, and I was telling you the value is fetched from record identifier. So that is also here. This is, if you see, customer data is 573291, and here if you see this part, right, record identifier value is string. This part I'm talking about, record identifier value is string is equal to customer ID. So if I give customer ID my record identifier,
then my values will come. So this is about, getting little hands dirty and practicing. I leave it to you to do it. And once you do that, and if you are interested in further, using it in your machine learning work, so there is one more, again by AWS, fraud detection with Amazon SageMaker. This notebook, you will find it on GitHub, and this page also. I will give you the link for both. Again, courtesy to AWS for providing such lovely notebooks. And here you will see an end-to-end machine learning pipeline of how to use the feature store in your training and inference both. Okay, so if you want to just get a feeling at high level, then first one that I showed you. If you want to truly understand end-to-end stuff, then this is the one you should go. Okay, both the links I'll give you in description. So please give me a thumbs up, guys, if you like this video. I'll see you all in the next video. Wherever you are, stay safe and take care.